So, hi everyone, my name is Gustavo, and I'm here today with my project partners Lucas and Mateus to talk a little bit about our project, which is about the development of a low cost AMR collaborative network in a manufacturing environment.
Hi everyone, my name is Lucas and now I will talk about our previous project. In the previous project, we developed a low-cost AGV which navigates by following black and white ribbons on the floor and stops when arriving at charge and discharge points or when identifying an obstacle along the way. We developed a separate electrical system into two different systems using Arduino, the security system and the navigation system. For the mechanical system, we decided to use aluminum profiles as the main structural component because aluminum profiles are light, strong, and versatile. And in your previous project, we studied a specific demand that a partner company presented. Then we developed the mechanical and electrical parts of our AGV to finally develop the programming.
But now we intend to focus more on the algorithm and on the artificial intelligence of our AMR in order to support several demands and allow simulations before having the prototype ready. Consequently, we will be able to develop customized AMRs for specific demands and also avoid expenses. Once the simulation will guarantee the functionality of our AMR in a specific environment for a specific demand before we really build it. And to do this, we use ROS, or Robot Operation System. ROS is a set of libraries and tools for building robot applications. From drivers to state-of-the-art algorithms, ROS has what we need for our project. In ROS, each functionality of a robot is segregated by softwares. These softwares are called by nodes. So basically, each node is responsible for a robot system. These nodes can communicate with each other through a channel. This channel is called by topic. Recently, we have simulated the navigation of a turtlebot in Gazebo, which is a software that allows the simulation of a robot navigation in a virtual environment. With the Gazebo running, we were able to create a map and navigate autonomously using Arvids.
Hi, I'm Matthew, and I will talk about the ROS2 machine-to-machine protocol. In essence, the protocol is called DDS and was built to be reliable and safe, to have high performance, to be an integrated system, to work in real time and with low latency. And last but not least, to have a scalable information exchange using the publish-subscribe communication model to provide reliability for the application. In this example, we see a self-driving vehicle using DDS. Each blue square represents an independent function of the application. They all work together exchanging information through the data bus. For example, the planning square receives information from the sensing and navigation functions to plan the most efficient path to the desired location.